Okay, so these are a set of images that I was provided. As you can see, there are 40 images, each 3 minutes in duration. And the goal is to try and see if we can detect a particular object, but that's kind of actually a secondary objective. The first being to evaluate the quality of the measurements that we're able to extract from this data set. And so the first thing I did was I went and ran the images through the Syntec tracker to pick up some of the brighter objects. As you can see here, I went ahead and put in limits that were relevant to the target of interest, but also these work well to find some other main belt asteroids as well. So in the process of looking for the target of interest, we also come across some other moving objects in the data set. So we'll go ahead and give this just a moment here to finish up and then see what results it comes back with. Okay, so let's go ahead and match up with known objects. So I'm loading the MPC orbital database, and then I'm also going to go ahead and load up the star catalog. And so the first object here, 2006 BA72. So I verified this track. As you can see, it's a fairly bright object, and so the initial expectation is that there should not be any issue with the measurements because this object has a good amount of signal, and therefore computing the centroid of it and so forth should be fairly straightforward. So let's go ahead and see if that actually turns out to be true or not. And by the way, I'm using 791 as the observatory code. That's not the actual code associated with this data set, but it's close enough. In other words, it's within the same region. So, but that's just FYI. So if we open up Find Orb, as you can see, we get fairly poor residuals, 1.3, 1.5, 1.2. And I thought, well, that's kind of strange. Is that just this one particular object, or other objects, do they also have poor measurements as well? And so here's another one. It's not quite as bright, and it does in fact tend to go in front of a star, if you will. But we'll go ahead and create measurements of this as well and see what happens. So this other object here, let's open it up and Find Orb as well. And so again, we get very poor measurements, 1.8, 1.5, 1.6. So I thought, well, let's just go ahead and see, let's simplify this a bit, and let's just run through image statistics module. And so this is where it's going to go through a bunch of catalog stars, which are stationary objects, and determine if it can get good measurements on those kind of objects. And so this will come back here in a moment with some results. And as you can see, as I divide the image up into more regions, the actual median residual of each region is actually quite good. So here we have 0.09 arc seconds, 0.08, 0.14. So very good measurements in general throughout the image, which suggests that it's doing a very good job of measuring stationary objects, because of course that's what these catalog stars are for the most part. And so that being the case, I thought, well, of course, the position of the object, its centroid, is only one part of the equation. So even though we're able to accurately measure the position of the object, we also need to be able to measure correctly the time at which we observe the object. And so I then decided, well, let's go ahead and change this time info setting. And so I just set it to refer to end of exposure. I had this happen one other time. Someone else provided me some data, and so that's where I thought, well, maybe this is the case once again. So we can take a look and see if that improves the results, and sure enough it does. So whereas before we had 1.2, 1.5, 1.3, now we have 0.38 is the highest residual. So this is a good way to if you run the data through image statistics module and you're getting very good measurements, but for some reason you have poor measurements on moving objects, then it's probably a time issue. And so again, most cameras, it seems, will output the date information as it referring to the beginning of the exposure, But every now and then I come across one where for some reason they decide to have it refer to the end of exposure. So you just have to keep that in mind. Other astrometry programs like Astrometrica also have a way for you to specify this, and so if you use other programs, then you would do the same thing. So it's a good way to troubleshoot a problem if you can isolate it to say, well, stationary objects have good measurements, so it must not necessarily be a position issue, but rather a time issue.